20-1. Another lesson involving everybody's favorites, word problems. Oh, how we love word problems. Well, we're talking about systems, talking about equations. Equations lead to everyday situations that we can try to solve. Now, last day, long lesson. Long lesson, the last one, because we did all solving processes graphically, and then 2 algebraic processes, which were substitution and elimination. So, algebraic, show your work. Graphically, sometimes you're allowed to just punch in your calculator, little second trace, number 5 intersect, scroll to the intersection point, enter, enter, enter. There it is with limited work. Great way to check whatever you get from your algebraic process. The other thing that we talked about last day that was new, because the solving was mainly the same, was the fact that we could have a linear system, which is what 10C was all about. 2 graphs, 2 equations, and a point of intersection. There's your solution. Well, we then introduced the fact that this course started talking quadratics. We could have a quadratic linear system, quadratic like anywhere on this graph, and then you have a linear equation could give you 2 points that are solutions. And the last one we talked about was the quad-quad situation. Quad-quad, have a quadratic, and you have a second quadratic, and it creates 2 points of intersection as well. So all of these 3 situations used the processes that we had learned in 10C. Graphing, substitution, and elimination. So it's taking this information in these processes and now doing them with word problems. How you solve, if it doesn't state, read carefully, the assumption is you're doing it algebraically. That's just assumed. Set up and solve algebraically. So with word problems, what's important is we need to, in each question, set up a system. We need 2 equations. And that's, again, like so many of these word problem lessons from this entire course, it's the setup that requires the thinking. The math process usually isn't too difficult. So understand what's happening. Here we go. Question number 1. Skeet shooter, doesn't refer to it, but it's a clay pigeon. It hits in flight. So you maybe see it in movies, or maybe you've done it. Someone stands and says, release or shoot or something, and a clay disc gets sent into the air in a parabolic trajectory. An individual with the gun shoots the gun, and at some point, the trajectory of the clay pigeon, it's called, and where the bullet's traveling from depends upon where it's released from, where the person's standing, but we have points of intersection. And that is what we're looking for, because like it says, we have a target. The clay pigeon takes this trajectory. We note that it is a quadratic. The -2 tells us it opens down. So there's the trajectory we're talking about. The gun is shot on a line, Ht is equal to 14T, where it does say in the question, but I didn't type it all up, it tells us that H is the height above the ground, and T is the time, it says, the projectile's in the air. So that's what we want to do. But what's nice with this one, as long as we can see what's happening, we have, and instead of going H at T, the height at a certain time, I'm going to turn it into an equation. Y is equal to -2t squared plus 20t, and the gun is shot where Y, and Y again, would be the height, so that's our Y. The height is based on 14t. Now, graphing it, you could graph it to check, but algebraically is how we should solve it. Different ways to solve. We could cancel or eliminate. We could substitute. I'm always going to use the one that I think makes the most sense. Here we have y is 14t. Not even a big equation or expression. I'm just going to substitute that in. So I can substitute 14t, since that's what y is, I can put it for y in the other equation. So our equation here would be 14t equals, that 14t has been substituted in, and it equals negative 2t squared plus 20t. So there's my start. At that point, well, what are we going to do to solve? Different ways to do it. I'm going to move everything to one side because it is a quadratic. I'm going to move everything over to the left side so that my negative 2t squared, when it moves over, becomes 2t squared. 20t becomes a negative 20t plus the 14t that's already over there, and that equals 0. At that point, we now can solve the quadratic by factoring or using the quadratic formula. Both were reviewed in the solving. Choose the one that makes the most sense for you. I'm going to factor because I can see with this, first thing I could do would be to factor out a 2, which would leave me with t squared minus 10t plus 7t equal to 0. Now I have my simple trinomial. What multiplies to 7 but adds to negative 10? Well, that's how we're going to factor. So when you look at this, hopefully some of you have caught my error. Oh, it's late in the day when I'm recording this. Bonehead. I don't have a trinomial because I need to combine my like terms. Oh, silly error. Focus. So at this point, I could still factor, but first I need to combine my two t terms. So I'm left with 2t squared minus negative 20 and 14 is minus 6t equals 0. Now I'm going to factor. It's not a three-term trinomial. I can factor out a 2t, which leaves me with t minus 3 equal to 0. Now that it's factored, I have my two factors. Basically, one of them is going to be a 0 if it has to equal 0. So t would be equal to 0. If that 2t is going to be 0, t would be 0. And the other possibility is if this t minus 3 is 0, t would be 3. So t equal to 0 and 3 are my two possibilities. But we always have to make sure we've answered the question. The question says how many seconds for the bullet to hit the target. Well, in that case, it doesn't ask about the height. We don't have to worry about it. We have two t values. Well, t equal to 0 and 3. What that means is my diagram, because I didn't know what it looked like, at times 0 they would cross paths, which means that the hunter, the shooter, would have been right there. That at time 0 the bullet would have hit down here. So it hadn't even been released. So really, what time? The time would have been at 3 seconds of flight. The target was hit. So, sorry about my solving. However, know what you've solved for. Why would we maybe substitute back in like we've done to solve for y? Well, we would solve for y if the question asked how high up. How high up did the target get hit at time 3 seconds? At time 3 seconds, the target was so high, but it doesn't ask for it, so don't worry about it. There's number 1. Now, second example on that page. This one, less about a real-life application, more about simple, straight-up word problems, reading and interpreting. Here, it's not a real-life situation. It's just number stuff. It wants two integers with the following relationship. Well, we see that there's two relationships here, so that means that's going to be two equations. But with this situation, this is where it's important to just identify unknowns first. We have two integers when we read this. 4 more than twice the first integer gives the second. It doesn't matter which is which, but I need to be consistent. So I'm going to call x my first integer and call y my second integer. Now I can create my equations. It says 14 more than twice the first integer. So twice the first integer, and I need 14 more than that. Gives, which is another way of saying equals, the second integer. So read careful and break it into steps. 14 more than twice the first gives the second integer. There's your first equation. Now we need our second equation. The second equation says the second integer increased by 1. So our second integer is y, increased by 1, is, which is another way of saying equals, is equal to square of the first integer, the integer squared. So there's what we have for our second equation. And now we need to solve. Which way's better? I don't know if there is a better, best way. Maybe I'll quickly set up both, but just fully simplify and solve for one. Let's take a look at elimination really quick. If we wanted to do elimination, remember one of my hints for elimination was to write the equation so things were lined up. So I want to write it as 2x. I'm going to move this y over to be a negative y, and then move the 14 over. So I just rearrange the equation. My second equation I want, well, in that case, I have an x squared. I don't have an x, so I'm going to move my x squared over this way, and it'll be a negative x squared. But now if I want to line things up, I need to spread this out a little bit. 2x minus y equals negative 14. So I have negative x squared plus y, and then my 1 would go over to be a negative 1. So if this is the situation, could I eliminate this? Absolutely. I have my two equations, things lined up. So what would I do? I now add the two equations. No x squared and a negative x squared is negative x squared. 2x combined with no x is a 2x. My negative y and positive y, I can eliminate. I had the additive inverse right off the bat. Will equal negative 14 plus negative 1. There's negative 15. So there's now a quadratic that I could use to solve. So elimination will work. How would I solve that? Well, solve a quadratic, everything has to go to one side. I would move my negative x squared over to be a positive x squared, which is helpful. My 2x would move over to become a negative 2x, and my negative 15 is there, so that's all good. And that'll be equal to 0 because everything has been moved to one side. So at that point, nice to factor this, multiply to negative 15, add to negative 2, x minus 5, x plus 3 equals 0. So this would tell us that x is 5 and negative 3. So there you go. That's the elimination. I'm going to leave it at that for a second because the second way is we could do substitution. Substitution should give us the same x values. Well, if I want to substitute, I need one of my variables to be isolated. Well, look at this. Y is already isolated. So that expression for y could go in for y in my second equation there. So I would have in this second y, I would have 2x plus 14 plus 1 equals x squared. At that point, Again, I have a quadratic now that needs to be solved. I'm going to move everything over to one side. Note that we have a positive 14 and a positive 1, which is a positive 15. So I'm going to move everything over so everything's on one side with a positive x squared. And there you go. X squared minus 2x minus 15. Whether we used elimination or substitution, we ended up with the same quadratic, which again, it would be x minus 5 times x plus 3. So x would be 5 and negative 3. So there's the possible answers for x. This question says solve this system algebraically after we write it. Well, that means we have to solve it. We have two possible answers. We have the answer x equal to 5, and we have the situation where x could equal negative 3. Well, I need to solve for the y. So I need to plug these values into one of my equations. Well, y plus 1 equals 5 squared. Subtract 1. Y would equal 25 minus 1, 24. So one possibility is 524. I would do the same thing if x was 3. Plug into an equation. Y plus 1 equals negative 3 squared, which would be y equal to 9 minus 1, y equals 8. Second possibility, x is negative 3, y is 8. So we have two situations, 524 or negative 3, 8. Those are my two integers. Now, we have to be careful, are both acceptable? Sometimes negative answers aren't acceptable, but in this case, we're trying to find two integers, positive or negative numbers. So a negative answer is perfectly fine. One situation could be the 524, first integer, second integer. It would suit all this. Second situation, negative 3, 8. That solution would also suit. So doesn't matter which way algebraically you solve it, you should get the same answer either way. Last one, question 3 in the notes. It's a little tricky. It's kind of wordy and hard to visualize. I'm not worried about it. You don't need to be worried about it. So example 4 is what we have. Read it, try to start the setup, and then we can talk. So if you've given it an attempt, let's see what you came up with. This particular question says ball is hit in a ball game. So in general, the ball travels on the path that's given. We see it's a quadratic, makes sense. The ball's going to be a parabola. But what happens is an outfielder is chasing after it, and an outfielder jumps up in the air to catch the ball. When an outfielder jumps, we're assuming in this case the outfielder is moving. So if an outfielder is moving and jumps, an outfielder will travel in a parabola. So what this question is saying is the ball was hit from home plate and the ball traveled a trajectory that was a parabola. Well, the outfielder ran to get the ball, and at some point the outfielder jumped, caught the ball, and then landed. So we have two different parabolas, and at one point the two meet. Note that x is the horizontal distance. If x is the horizontal distance from home plate, this x value here is how far from home plate the ball was caught in a horizontal distance. And it tells us that y is the height of the ball. So the height in this case, y, that's how high the ball was when it got caught. There's only going to be one point here of intersection, I think you would find. I don't think if you were to do this on your calculator graphically, you're going to get 2 points of intersection, really, because that's how the question would look. So here we go. What do we know? We have h is equal to negative 0.1 x squared plus 2x. And then we have h is equal to negative x squared plus 39x minus 378. So with that being said, well, different ways we can approach this question. It's up to you as to which way you do. When I look at this, I kind of like the fact that I have an h and an h. They're not additive inverses, but I can make them additive inverses and eliminate one of them by multiplying the whole thing by -1. So I would have now, if I rewrote it, negative h equals positive 0.1x squared minus 2x and nothing else. So after multiplying everything by -1, I can cross off my additive inverse h's, which gives me 0. I have a negative x squared equal to 0, or plus, sorry, because I'm adding all of these, 0.1x squared. Well, that's going to give us a negative 0.9 x squared, and from there 39 and -2 is plus 37x minus 378. So there's what I have for my quadratic. I'll be honest with you, factoring that could just be plain old ugly. So how would we solve it? Well, we would solve it quadratic formula. X is negative b plus or minus the square root of b squared minus 4ac over 2a. Well, now I plug all of that into this. So x equals negative 37 plus or minus the square root of 37 squared minus 4 times a, which is 0.9, times c, which is negative 378. All of that is over 2 times negative 0.9. So now, when I would go to do the work here, well, I'm going to save all the steps, but what I have here under my radical, and after I were to root it, we would end up with negative 37 plus or minus 2.86 over negative 1.8. There's what our quad formula looks like. So you can double check that. Like I said, should end up with plus or minus 2.86. So that means our x value will be negative 37 plus 2.86 divided by negative 1.8. And the other possibility would be negative 37 minus 2.86 divided by negative 1.8. So we get x values equal to, what do we get for x values? 58.8. We also get x equal to 18.97. So there's the two x values. Have we answered the question? What height was the ball caught at? Well, height is y, so we need to get y's. So the first y, if I were to plug in, I need to substitute into one of the original questions. My y, or height, would be negative 0.1 times 58.8 squared plus 2 times 58.8. Sorry, I'm running out of room here. I write and scribble too much. Let's see what I can squeak in here. So the height, y, would be negative 0.1. Our first x, we believe, is 5.8 squared plus 2 times 58.8. And when we solve for that, well, we get, I'll be honest, it's a negative. And we know we can't have a negative height, so that's just extraneous because we can't get a negative height. But if I do the same thing and I use x equal to 18.97 squared plus 2 times 18.97, when we calculate this one, we get a y value of 1.95. So that makes sense because our height would be above the ground or the x-axis if we were thinking that way. So at about 19 meters away from home plate, the outfielder caught the ball 1.95 meters up. And that could go into a sentence. So in this case, algebraically, I eliminated process, but I had to use the quadratic formula because this quadratic was ugly. One answer ended up being extraneous because it didn't make sense to have a y or height value that was negative. Word problems. You got to do the math, but you got to do some reasoning as well. So, more practice. Textbook, page 436, number 11, C and D. Try that one graphically. The numbers are a little ugly, so practice working with your calculator. But these other questions, attempt those algebraically. Great practice. Please, some people were asking as well, practice. There is in the booklet questions on solving systems of equations that haven't been assigned. If you want more practice there, it's there for you. Lots to do. Have fun.